What is up, YouTube? The topic for this video is implementing data quality within your ETL pipelines using Great Expectations. So Great Expectation is like a data validation, data quality framework built exactly on Python. As a data engineer, when you're kind of building pipelines, your data is being used for some analytical or insight purposes, or even like predictive insight purposes for data scientists, right? So it can be used either as like essentially a table which a business analyst refers to get his insights, or maybe as a dashboard being used by some certain C-level executive to make for decision making and whatnot, or even as a data scientist can be using this data, whatever you're building for the models. If on a morality level or a high level, if you think about it, if the data kind of coming in is baked in with data quality issues, or like the data is not correct, the values are not correct, there's some missing data, kind of really undermines the effort you kind of put in for building all this pipeline, and also kind of undermines the effort of people using that data set, right, for like insights or decision making by C-suite, whatnot, right? So it kind of also on a moral ground, data quality is like really important, at least for me, right? So hence comes frameworks like Great Expectation, which kind of try to put together your all data quality needs in a single place, where you can lay down these validation called expectation as declarative syntax, and it can be validated, it can be documented and shared and whatnot, and then you can do alerts and whatnot. So there's a lot of things going on within a single framework like this. Essentially, if you look at your workflow as a data engineer, the first 3 steps, 1, 2, 3, is basically concerned for a data engineer. Then you kind of load it into a warehouse, it's being used by other people and whatnot, right? But on a day-to-day ETL, on a day-to-day for a data engineer, having data quality implementation, that's where kind of Great Expectation kind of comes in between these 3 steps. Is when you do extraction, you can have good amount of data quality checks in place, especially when you're pulling out data from different sources. The quality usually doesn't match, like the column names don't match for different countries. These kind of things can be really ironed out using a frame like this. So once you at a data ingestion phase, you can easily have a implementation in place, and then after the transformation for your final models, for the silver layer or the T2 layer, you can have another set of checks also in place before you kind of load in the data, so that everything is up to the quality before loading it into a warehouse, right? So if you hop onto the website, you can see the 2 different products being offered by Great Expectation. The one thing is GX Core, which is the open source framework developed by Great Expectation, and then there's GX Cloud. In this video, our key concern would be around GX Core, on how you can use this Python package or open source framework to kind of implement these data quality checks, right, as an introduction. This is on a high level what Great Expectation has to offer. So on the left, you can see the data sources which get connected to Great Expectation as a framework. So it's very easy to connect different types of data sources, which includes databases, actual databases like PostgreSQL, data warehouses including BigQuery, flat files. You can connect to flat files. You can connect to flat files in file storage, local storage, or object storage such as S3 buckets or Google Cloud Storage. You can connect to data frames directly, which are in memory from pandas, or like the ones like the data frames from Spark. You can do either. So it's very easy to connect to these data sources. Then you can kind of spin up your expectations, which are basically validation or quality checks. You can write down those expectations in a structured way, and then this produces high quality data products, right, in your pipeline. So it kind of pushes all the checks for your data pipelines, and then you get validated data. Second, it actually enables you to document all these validations, what kind of validations you put in, what kind of data is able to meet the criteria for the validation, which ones have failed, what number of records have failed, what kind of criteria are being measured. So it kind of ends up at the end it kind of comes up with a report, like a documentation, which is enabled by this framework. So it's easy to share. This is also another criteria where it's kind of easy. It's kind of helping you out in terms of communication on quality, right? So a lot of the times you implement checks, but you're not able to communicate it properly. This framework kind of helps you build a report or a documentation. You can share it with business users, so there can be a to and fro communication, right? Another thing you can do is like enabling logging and alerting. You can log those errors, what's happening. You can set criterias. on those logging, right? What kind of number of records passing the criteria, numbers not passing, you can push them somewhere else. Another thing is you can raise alerts if things are failing. You can raise it alert on email or like all the other different communication channels. You can do that, right? So on a whole, this is how Great Expectation is trying to help you in a way. On a high level, that's how it looks like. Let's quickly look at how the exact workflow, Great Expectation workflow looks like. It is kind of consists of 4 steps. The first one is setting up of the environment, the Great Expectation environment, which is done by defining the data context, right? So data context is essentially an object from the class when you import the library, instantiate the class, right? And that's what is called the data context. It has all the metadata, all the values, or all the assets are being registered within the context. It's very similar to other contexts like Spark context and whatnot. So that's where you set up the environment. The next is connecting to the data. The first is defining a data source, which basically a database. It can be an actual database like a PostgreSQL, or it can be a data source can be limited to only files, like sets of files or sets of Parquet files you're looking at, different data sets you're looking at. So that's like a data source, maybe like a bucket, and then all the different data sets within it. So you can even call that a data source. A data set essentially is a table, is a set of records, right? So a table or a data frame can be a data asset. Then comes batch definition and basically a batch. So when you're testing data sets, it's only not limited to the whole data set. That's where the term batch definition kind of comes in. So you can consider, like, if you want to split an existing data asset, which is a table, into multiple batch definitions to test different sets of expectations or like quality checks, right? So for example, you can think of your table kind of consists data for different countries. Obviously data coming from different sources or for different countries can be different, so you have to kind of define different expectations sometimes. So this can kind of enable you to break down your data asset, which is a table, into chunks of batches, and then you can run your expectation suites or different sets of expectation, right? Then comes the expectation definition part. This is the actual validation checks you kind of implemented. So expectation is an individual check you apply. This can be maybe like a null value check on a specific column. This is one expectation. You can consider it. You can have multiple number of expectation, and you can kind of build an expectation suite of number of multiple expectation. So in a way, you can kind of define it as a for different batches. You can define different expectation suite. So you can run all these expectations as a suite in a single go. So it enables you to organize the building checks and then running them on different places. This is how like expectation suite kind of enables you to do that on batches of data or even the data asset, right? All right, so then kind of comes in validations. You run the validation. The first thing is the definition of the validation. You basically validate the expectation on a batch of data. The batch can be a full data table as well, right? That's the definition. And then there's the validation result, the output of that validation that comes in usually in a JSON format. That's like the metadata coming out. There are checkpoints, there are actions, and then there's data docs. The checkpoints are like in between places when you want to point at. We'll cover that also when we do the tutorial. Actions is when we want to do certain things based on certain criteria. Maybe things are failing, you want to send an email. So those are actions. And then there are docs where you want to document this set suite of validations you have kind of put in. You want to show it to someone as an output, something like that. All right, next thing I want to talk about is the different type of integration that comes baked in with Great Expectation as a framework. They try to be as an end-to-end solution in terms of data validation and quality. So what they have done is they have come up with all these native integration with all the key data technologies, data tech stack technologies within the area, which includes like different data sources where the data is coming from, notification actions with like emails or like connections with like Slack and stuff like that. Configuration stores, like object storage, it kind of connects natively to very easily, like S3 buckets, Google Cloud Storage, etc. Orchestration, it really natively connects with Airflow. There is an operator within Airflow to execute all these expectations, validations. Like once you create it, it's very easy to do that, and it natively integrates with notebooks, right? You can easily import a Python package, run this expectation validation, get the output reports, actions, and whatnot. So you can do it very easily. Another thing I wanted to show was the expectation library. So basically, Great Expectation comes baked in with all these different types of validations you would want to put as in terms of, they call it the expectation, right? So it's basically pre-built expectations are already given to you, and you can basically look at whatever you want to implement, right? Data, it ranges from data quality issues, integration, cardinality, schema detection, etc. So it basically comes with whatever you need. That's the way I feel it. In some cases, if you want to, you can implement a custom expectation as well. Example of some of these expectation includes like expect column distinct values to be in set. So if you're maybe, for example, you're looking at country, you want to just check if in all the countries in your list has the data. You can just have a very quick check by adding the set of countries you want to check for. So it can range from looking for different columns. It can range from main and wax values or evolve column, distinct values in a column. So these kind of stuff are basically built in expectation. You just need to import it from the package and use it. So let's get started with a simple tutorial for you to kind of understand how a Great Expectation workload kind of works. So the first one is to kind of setting up the Great Expectation environment. That's where we kind of define the data context, right? So if we move back, that's the first kind of step we actually do. First two steps, I would say. We first of all import the library. As a first initial step, we are basically creating a context, a Great Expectation context with the mode file. What this mode file does is basically it stores all the metadata and artifacts in your local file system in the directory, so for you to reference and maybe even commit as well in your repository. One more thing I am doing is I'm adding Google application credentials. I'm using Google Cloud Storage, which is object storage. You can use S3 or Azure as well, right? So just keep that in mind. Our data set at the moment is in Google Cloud Storage, right? So more about the data set, I'm basically referencing this Go IBPO flight data set. It's just a sample data set where I wanted to show some checks on a few columns, nothing very specific, but more about the data set is basically flights data set, flight date, airline, flight number, to and fro, departure city, arrival city, timing, and whatnot. So this is the data set which we are going to reference. What I have done is I've downloaded it and put up in a Google Cloud Storage. I just wanted to showcase how you can work with Great Expectation with cloud. Is very easy to do. Comes basically with an inbuilt integration. You don't have to do much, right? So hence we need this credential. This credential is just a path to the JSON service account here, right? That's all. Yeah, so we have the context. As a next step, we basically define a data source. So if we move back to our diagram, the next step is to kind of connect the data, get the data, reference the data, right? Just connect to it. You can execute these expectations or validation on a bigger and complex projects with more hierarchy, more organizations within project. You can have multiple data sources, and within those data sources you can have multiple tables. Within those tables you can have multiple records just to validate. It's just hierarchy they are coming up with, so that you can easily expand this project when your project grows, when your validations about testing of your data kind of grows, when your needs kind of grow. That's all. So after context, we define the data source. So consider as discussed, this is a database. So we call it flights data source. For the referencing, I'm just using context to add as a pandas GCS data store. That's what we are referencing to it as, right? It's like a predefined function where we are referencing that file. Not the file yet, but we're referencing that bucket at the moment. That's where we just call it as a data source. So the bucket name is flights dataset YouTube tutorial. As this is in line with whatever we have put up in the cloud storage, right, for your reference. Next is to define the exact asset. So in real life scenario, there will be multiple assets, multiple tables within a database, but in our case it's just one. We are referencing the Go IBPO flights data. So the asset name is the same, and the GS prefix, it can be a proper prefix with multiple folders. In our case, it's just a file there in the bucket. So what we do is we add a CSV asset and we provide the name and the prefix. And as a next step, we define the batch definition. Also, this is an organizational feature for Great Expectation. From Great Expectation is that within a table, you probably want to split your data for multiple validation. Maybe a single validation doesn't fit your criteria needs for all the rows within a table. It's something like that. So maybe you have different data sources and kind of coming it together in a table from different countries. So to checks and validation, there's a lot of times the checks and validation are actually very different for those different countries. So within a table, you can define a batch definition. So we call it a batch definition, a batch, and we kind of provide the specific batch in that definition. Hey, in our case, we are just using the whole table as a full batch definition, but you can kind of split it based on your criteria or your filters and whatnot. Now, within the GX workflow, the next step is to kind of define expectation. It consists of two parts. One is the expectation and the expectation suite. So expectation suites consist of multiple number of expectations. This is also like an organizational feature within GX. So that, hey, you can have an expectation suite with a list of expectation defined. We can run this in different multiple data assets or multiple batches, right? So just keep in mind, in our case, we are defining an expectation suite and we are adding multiple expectations within that expectation suite. So if we go back to our code, we just create an expectation suite named flight expectation. Then we actually define two expectations for now. We're keeping it simple. The first expectation is expect column values to be null. So we not null. So we want there's non-null values within this column called airline. And then I'm defining another expectation is that where the class of that flight is either economy or business. That's how the dataset is right at the moment. There's no other value within that column, so we just want to validate that, hey, only these two values kind of exist. But when you're defining your expectation, you can always refer to that expectation gallery. So yeah, once you define these different expectation, you add both of these expectation within the expectation suites. After we add the expectation suite, we define a validation definition. So a validation definition is basically another organization feature. If you think about it, it's basically a reference between a data batch, and then the expectation suite. So basically referencing these two and executing them, right? And then you can have a list of different combinations and permutations of the batch of data and expectation suite you want to do it. It just help you organize in a better way. So we define a validation definition. We call it the flight batch definition. Within that validation definition, we provide the data, which is the exact batch definition we did. And then we provide the expectation suite we created. So we're just mapping them together. It's very simple, right? And after that, we basically run this validation definition, which will run all these different expectation suite, all these expectations within expectation suite. I know it gets complicated, but yeah, I think it really helps as you try to grow the project. So the expectation suite being run on that batch of data, right? So that's what we're doing here. So we get the results after doing a batch validation definition, and we just do a run. And you can basically print this validation result in your console as well. Another step you can do, which is optional, obviously for more complicated systems makes sense, is have actions and with checkpoints. So basically you can have different actions being performed if some expectations are passed or some expectations are failed. That's how you can define it. Notification can range from like an email to a Slack notification. These are all first party integration that comes out of the box in Great Expectation. So that's where you kind of define, hey, there's a Slack notification channel. I want to pass this information on a Slack channel. You have to provide some key details such as token and the channel name. This usually comes from the environment. I haven't published that, but that's how you could do it. And then you update that checkpoint once it executes in your Datadog. That's all. So you define so the way the checkpoint executes is like you have multiple validation definitions. Obviously you just don't have only one validations, right? You can have different validation because it's like a combination of expectation suite on batch of data, right? And then you can have different action lists. It can't be limited to just one action. It can have multiple actions. That's the flexibility of the framework. And then you can just define that checkpoint. So that checkpoint is that validation list of validation definitions and the action list is what you want to do. And you have to provide a result format. There's a few options there. In our case, we're providing complete, so you get all the details when you run these checkpoints, right? So yeah, after that, the last step is basically you run the validations. That's all. So yeah, this is how all the different steps kind of look like. If I run this, all these steps in my interactive window on the right, then I can see the steps being executed, like all the different ones, right? And towards the end, you'll see the output of the checks you did. That's how the validation results looks like. I'm just printing those, so it's basically calculating that how the checks performed, kind of provides, hey, these many elements we kind of checked, and for this specific column, and this is the result, and everything is expected and not expected and whatnot. So get all of this detail. If we go back, it basically creates a folder in the file mode where all the checkpoints are defined, the expectation suite is defined, right? And all the details, like all the output is also defined. So all the metadata kind of gets stored into this GX folder. You can change the name of the folder, you can define it at a separate place, maybe in the cloud as well if you want to do that. But this is how it kind of looks like. Comes up with a GXYML where it defines all the metadata where it kind of exists, right? Another thing, it gives you out, which is the uncommitted folder, the output of the data docs. Comes up with a formatted output for your validation. So yeah, once you open it up, this is how it kind of looks like. It has all the details of like the validation results, the expectation suite, the location of the data docs, right? So if you go at the expectation suite, it shows you the exact expectation we kind of created. This is our expectation suites with multiple expectations, right? So these are all basically the validation checks. It comes out with a very formatted document, right, which is easy to share, right? And it's very easy to understand if you think about it. So it basically defines, hey, airline values will never be learned as part of our expectation from this data set. And then the distinct values within the class, like, should be economy, which this is what we define, right, in our code. So it already is giving you the expectation suite. Then we can always go back to the results of the validation we did. You can have multiple runs of the results, and it will show you as a list of the results. In this case, we just did once. So if you go to flight expectation, so this is the result, right? If you click on it, you'll get all the details. Evaluated expectation 2, successful, both of them are successful. The success percentage is 100%. So it's basically saying everything is looking good in the data set. So if you have more comprehensive checks, obviously things will fail, but the good part is it will be documented and you can easily share it through. You can send an email as I kind of showed if things fail. I'm going to play around more with great expectation, and if I have more insight or more details, I will come up with another tutorial. If you want me to come up with another detailed tutorial, I will do that as well. Let me know in the comments. It feels real nice to kind of film a tutorial again on my channel, right? Thanks a lot for watching my previous videos. And yeah, that's about it. If you like the video, please leave a thumbs up and share it with your friends and whatnot, or in your circle and whatnot, right? Just do that. And thanks a lot for watching. See you in the next one.